Okay, I just want to do a little quick video. I know a lot of people's done these videos on YouTube, so you know, I'm not going to go through all the steps in detail, but I do want to show you my particular setup and exactly what I've done to get my whole house powered with a hybrid. I've got the dual fuel DuraMax 13,000, and that is obviously running on gas. You get 13,000 max amps. I will be running this on LPG. This will run on propane. I do have it already plumbed and ready for that, and I am going to be powering my house via this 15 foot. Now you can go up to, I think, 50 foot with 6 gauge, but I don't particularly need that because I'm going to be going right from my breaker box right here to the edge of my garage, right on the outside. Just in my particular case, obviously you want to be cognizant of carbon monoxide, so the generator won't be inside, even though this has carbon monoxide detectors and automatic shut off on it. But yes, a lot of people actually just tend to forget how that carbon monoxide can build up pretty quickly, especially with the wind blowing back in your garage, etc. So you want to be quite careful of that. But yeah, so this is like an LP50 50 amp, which will go right into my generator here, and this will be the Nema side here, which will plug right into my adapter. And let me show you that. I got this on Amazon as well. So all this stuff, I'll provide links on Amazon just so you have the exact specs. And this is a SS2 50 amp. So it's a 240 volt 50 amp Nema plug here. So it'll plug right in there and it'll twist the lock. And then you have a little outer collar which will tighten down and keep it from working loose. Not that it would. So I believe this little lightning bolt lights up when there's power supplied to it. So if, per se, you had the main breaker on and you had your generator breaker flipped, which will be the in feed here, it would show that you have power going into that. So obviously you wouldn't want to plug up your generator and crank that up. That'd be bad. But also it's just showing you, just giving you a little indicator here so you're careful not to touch these prongs or any of this while this stuff is hot. Just a little safety feature. Not that I particularly would say it matters for me, but it's kind of nice to have. So what I've done here, and I'll show you the interconnect kit here in a minute, which is very important. But what I'm going to be doing is wiring this right here next to my breaker box. And in my case, that made sense to me, although some people punch through the back side of the wall and they mount this bracket and Nema connector on the back side so they can have the generator on the other side of the house, quiet, etc., keep it away from the house. I get it. But in my case, I wanted it inside the house, and it doesn't really matter. But what I did was I just punched a 2-inch little hole here, and I took my hole saw, cut right through, no big deal, went right through a stud. So that's going to give me a little short run, which is what I want. Now let me bring this over here and show you in my particular case how I've got this mounted. So I obviously on this bottom left, we've got 3 mount points. So I'm going to be going through the back grommet there, feeding through up and around into my box. But I've got 3 mount points, so I'm going to use some drywall anchors here on the these 2, and then on this left one, I'm going to use just a standard drywall or actual wood screw, Torx head wood screw, which will give me a pretty strong connection right into there. So that'll mount just like that, and the wires will come through and connect and give me a nice strong connection. Now on the back side of this Nema plug, we're going to have 3 connections, pretty simple. They are labeled. The one that really matters is the neutral wire. That would be the white wire. So the neutral wire, you just simply shave off. You want about, I don't know, a little less than a 1/2 inch, 3/8. You want to be, each one of these is different. So you don't want any copper obviously being exposed out of that hole, but you want enough to where you've got a good solid connection in there. So really it's just common sense. Let that neutral wire sit in there, and then the other 2 don't matter. Those are both 110 legs, so you're going to get hot on the black and the red, and it won't really matter which of the 2 you pick. So no big deal there. And again, just showing you my particular setup and how I'm going to run that. Now in my case, I do have 2 50 amp breakers. So from my generator, I will be coming in with a EATON 50 amp generator. So I'm just going with the same breakers, same manufacturer that's already here. So these breakers will go down to fit 2 more 220 breakers. I believe it's like my hot water heater. I'm not quite sure what those 2 are, but it doesn't matter. The generator one will sit at the top, which will allow my interconnect kit to interface with it, and I'll show you that later. So the generator one, which these wires here will come up and connect to, will be at the very top, and then my welding breaker will be probably down here below these 2. And I'm going to mount me a welding outlet plug somewhere over here. That's not part of this YouTube, so I will not talk about that. But yeah, so for the most part, I'm just going to feed the wire through. I put a little bend on it there, and then that way it just comes through, and I got a nice curve to fit right through, feed right through there. So not much to it. I think anybody with some common knowledge of you know, construction and a little bit of fabrication with electricity wouldn't have any problem doing this. Now, I don't recommend anybody fooling with a breaker box or doing this type of wiring or setup without the at least consultation of an electrician, or if you don't know what you're doing, just have an electrician do it. Obviously, you're playing with something that can kill you pretty easily, so just don't. It's not worth it. I've done quite a few of these. I am not an electrician, so please don't take my advice. I'm just showing you my particular setup just for demonstration purposes. So now I've got my 3 6-gauge runs here. So my neutral and 2 hots, which will go to my connector and then up to my breaker, my Nema connector and my breaker. And I have a 10-gauge ground wire. So my ground wire is does not have to be as thick as the wires that are going to be supplying current. Just note that. And I got these wires again off Amazon. So everything, like I said, I'm going to put the links to where I bought from Amazon, and I'll show you all of that. So one thing to note, I'm going to be powering my entire house with this setup. So for that to happen with a 13,000 amp generator, and obviously that's max, that's starting amps, or that's max amps, right? I think it's 11,000 running amps on gasoline, somewhere around there. So even lower on propane. So with that in mind, for me to power my entire house, I did go with a soft start kit. So if you don't know what a soft start kit is, they've been around for a while. There's hard start kits, there's soft start kits. There's even guys who've been doing stuff comparable to that back in the 90s, possibly even 80s, before they even were called hot start kits. But the idea is to gradually ramp up the amps, or the startup amps, on your air conditioner so that your generator can handle the load. You just don't want to like flip the switch and turn on the compressor, turn on the fan, crank everything up all instantly, which will essentially cause too much of a load on your generator and could possibly kill your generator every time the AC turns on. So in my particular case, I went with the AIRGO AC Soft Starter. I believe this is around $290, 300 bucks. This is a single phase, which will probably be the majority of you guys running home air conditioners. It is single phase. So, and what it's really doing is it's reducing the inrush current. It's gonna, you know, a lot of times when your AC starts up, especially in older homes, your lights will kind of flicker, that kind of stuff. It will reduce that. It helps improve sensitive electronics because you're not introducing like voltage, you know, current irregularities in your system where you have spikes and then drops, etc., because your current's being stressed. So it helps with that. It also says that it helps stabilize utility grid voltage. Don't particularly know if that's true, but I'll take their word for it. And it also, and what I've understood is that they also reduce compressor stress because they gradually ramp up the compressor instead of that hard inrush of amps on the compressor. So again, don't really take my word for that. This is just what these soft starts are known for. But the majority of why people get these soft starts, at least to my knowledge, and the reason why I'm getting one, is so I can power my home off of a generator that's not like a 26K generator, some Generac or Kohler, you know, generator that's $20,000. I don't care for that. I don't lose my power enough for me to warrant that type of generator. And also I don't want a generator that's fixed outside because we do have flooding here, and I want to make sure that I can move my generator wherever I need and provide electricity ad hoc, however I need it. So that's what I'm going with. Now, AIRGO, the soft start kits, they do offer 2 different kits. I have the 1632. I believe they have an 816 kit for smaller tonnage air conditioners. Mine's obviously the larger, so I went with a 1632. And I've had this wired up now on my Train AC for about a week. I can do a video on that if some people want to do that. There's plenty of them out there. Don't necessarily know that I need to go through that. But if some of you have some questions on how the AIRGO is set up and want some instructions and maybe some videos on that, I can provide that. But that's a picture of it. It's really nice. It's got a metal casing and comes with all the wires, instructions, everything you need. And why I went with AIRGO, I saw in the comments that the CEO of the company, who's a master electrician and who's behind all this, will actually take your call if you have any questions or phone or just anything, any concerns about this product. And actually I did. I had one question about the relay, one of the wires that went to the relay. I just wanted to be sure, right? Because you're talking, you know, a lot of money in your air conditioner. So didn't want to wire that up wrong. I knew it was right, but I just wanted that extra bit of just, you know, confirmation. So I picked up the phone 7 o'clock p.m. and called the number on the card to give you a business card, and he picked right up and answered the question without hesitation. Sounded pleasant to talk to. So again, how many companies can you do that? That to me is phenomenal, and that's why I love supporting small business and products like this, because just they have good people behind them, and anytime you can support that, I'm all for it. So here's my interconnect kit. This again was bought on Amazon. Comes with you know, a drill bit, some hardware, a template, etc. And this is aluminum. Just looks like pressed aluminum, or it might have been cut out with like plasma or something like that, or even a water jet possibly. But it's very clean, looks super nice. Comes with stickers and instructions that you can put on your breaker box. Comes with a couple of zip ties as well. I guess that's maybe for installation, but really nice. And this will allow me to make this thing legal, and obviously, where the most important thing, no chance of backfeeding power down the grid and killing some linemen, who I have quite a few friends who are linemen, and I don't want that to happen. So protect those guys out there doing their job. Interconnect kits, like 20 bucks, a little bit of work. No way in the world would you not do this. So this is by far the most important thing that you need to do if you're planning on wiring up your generators into the house. And I know a lot of people do stuff last minute, like wiring, you know, going through the generator plug, etc., into the main, and sure, that works, but man, I mean, you know, it's just not worth it. Just take the time, be prepared, do this stuff ahead of time, and you'll have a nice setup that'll last, you know, as long as you need it, as long as life of the house, really. And you'll be able to provide your family with power whenever electricity goes out. Anytime you lose grid power, you're ready to go. So I'm going to stop here. I'm going to go ahead and mount the box, and I'll show you the next steps of where I'm at in this process. All right, so what I decided to do was, instead of going with like the standard clamp, which would essentially clamp these wires down and keep them from rubbing, I have a nice rubber grommet, which I decided to go with, and it fits very nicely in there. And the idea is just to prevent this wire, although it really shouldn't move, but again, you just don't want it leaning on metal where I popped out that center section. It is a little sharp, so putting a rubber grommet in there helps prevent these wires from ever rubbing. All right, so next I'm going to strip off the wiring here, and we're going to feed that through the box. So I'll tell you what, I'm going to strip some wiring off here. So let's start with that. Just like that, we want about that much. Go ahead and do this one. Now I need to feed the ground wire through, so I'll do that here in just a second. So there's our red and black. Those are our two hot wires. Here's our neutral white wire. And on the Nema plug, it is labeled W for white, and that's our neutral. And the other two wires won't matter. So they're both providing 110 volts. So there we go. Nice 6 gauge. Okay. So what we want to do, let me go ahead and feed this wire through. And then what we'll do is we'll mount the back of the bracket on. Go ahead and mount that. And then we'll feed the wires through and mount them into the Nema bracket. So I just want to put a little curve on there. A little tough because I've already got these wires in there. But if I feel, I should be able to get that wire. So let me put a nice curve on there and feed that through. And I should be able to see that green wire come through. Where's that green wire? So I feel it. It's a little bit long. It's right there. So sometimes not the easiest thing when you got big fingers. So let me get these wires out of the way and bend that a little bit more like that. See if I can get that through there. What's interesting is the other wires went through pretty easy. All right, there we go. So we got the ground wire through now. There we go. All right, there's our ground wire. All right, So if we back up just a little bit, and then so what I've got to do is got to feed all these wires now through the back of this box. So 1, 2, 3, and let's get this other wire, ground wire, through there. Okay, so go through that grommet. So these grommets are not pre-cut. They are closed, so you want to take a razor blade and cut opposing 90 degrees, so just 90, 90, 90, 90, and cut those slots out. That way you can fit those wires through whichever grommet you see fit to use. So now that I've got this in a good position, all right, so back up just a bit. So let me grab my drill, and what I'm going to do is I'm going to start, tell you what, I'm going to start with Phillips head on the drywall anchors that I already have there. They are the most sensitive, so I'm going to make sure I have those lined up well. So that's our drywall anchor. Nice. Okay, here's our second drywall anchor. I'll grab that one here. Okay. Okay, there we go. A little easier if I was using a drill or impact, but let me get this one in there. Okay. And what I did was I took a level, made sure this was level. Obviously I know there's a stud there. I don't need a stud finder, and I know there's not a stud there. So I just put my 2 drywall anchors, and then this one I'm going to come through with a standard self-tapping wood screw, which is a hex drive. And I'm going to come through in an angle because I want to make sure that I hit my stud completely. Just like that. Just like that. So now we've got a very solid connection on this box. This is not going anywhere. Right, so our ground wire, now I can pull these through. The ground wire is going to go right up here, and it's going to connect with the other ground wire on this box here. So what I'll do, I'll strip this off. Let me get enough. Okay. Now grab my Phillips head, and let's back that out. You know, I am working without my glasses here, so a little bit tough. Let's back this out. And before I do that, what I'm going to do is I'm going to go ahead and pull these other ones through. I think it'll be easier if I do that. So let me go ahead and pull these through just a bit. And I'll go ahead and get these started into my Nema plug here. So I don't need my glasses. All right, so on here we've got a white and we've got a Y and an X, and obviously your ground. So our white is going to be our white wire. So we just want to back out these screws that are on each side, and you want to make sure that if you get down in there, your copper, where your insulation and your copper meets right at the top of where your connector opening is. So that way, if your finger was anywhere around here, you're not going to get shocked or electrocuted, but you've got full copper exposed down here on this connection. So let's tighten that. Just like that. Now it's, like I said, doesn't matter for these two. Let's pull a little bit out so that way I get a nice tight connection in there. There we go. Tighten that. Okay. And then let's turn this just a bit where I can get to it, and turn it down where the gravity will open up the hole there a little bit for me to get the wire in. And then we'll tighten that down. And again, you just want them snug. They don't have to be crazy tight, but you want them in there where they're not going to move. All right, so what I'm going to do is just pull these through. And this connector box goes like this. So let's go ahead and kind of get the wires turned in the way that I want them. And let's get that ground wire up there like that. So now that we got this in a pretty good spot, let's bring that ground wire up. So this is going to go back just like that. So let's give me a little bit more slack. Okay. Now let's take, and we want both of these ground wires. So you want that ground wire like that, and let's make sure that we get that ground wire there just like that. Okay, so now if you can see right on the front of the face, we got both of those ground wires. Nice. And if you come in and you get a straight shot on that, straight shot like this. Okay. All right. Okay. Tighten that down. All right. So now that we've got all of our wires connected. A little bit of drywall dust out of there. So let's pull these wires through. It's going to go up just like that. You want to work it back, but you want to pull. That way you don't pull the wires out. And this will go right there like that. Let's get this outer. So you want it to fit right on the outside there, just like that. Let me take my screw off. Actually, if I could probably come up, I can come down on the screw. There's a screw on the very bottom. You back up and get that. Screw right on the very bottom. So if you get this just right, you want this box to hang on the back and snap right in there just like that. Okay? And we'll tighten up right here on the bottom. Just like that. So now let's make sure our wires are not bound in any way. We're all good. And then here's our, and that actually has a nice little click to it. So it seats up nice. It's not spring loaded like some of them are. It doesn't really matter to me. So the idea is that you just have a nice strong hold on that stud, and obviously the drywall anchors. And hold that right there. I'll show exactly. So back up just a little bit, and I'll show you how this Nema 50 amp plug will plug. So they got little notches in here, so they do fit a certain way. So you'll see that they're kind of some little notches and ridges, and you just want it to fit right in. So it'll slip right in and then turn, and that's it. And then this little black little collar, you got everything lined up. You want to be careful because it's kind of thin plastic, not the most heavy duty thing here. But yes, when you have that fully secured, you don't want to over tighten it because obviously, again, it's not a very strong piece, but you just want it snug, and there you go. So if you come back a little bit, you can see that now will feed right into my generator. We've got these, the black and the red will come right up my breaker here. I don't want to get too close because we are, possibly with power here. You just want to be careful always. So I'm going to come up to a 50 amp breaker with both 110 legs. That'll give me 220 into my both bus bars, and then I'll come into my neutral bar, my common on that side, and then my ground here. So we'll do that in the next video. Thank you for hanging around this long. Okay, picking up where we left off. Yes, I'm getting old, so I'm going to put my glasses on here. But where we left off, we mounted our Nema box, our 50 amp, in from our generator, coming in mounted to the drywall with a couple of drywall anchors and one stud screw. And so I'm now going to take and separate the 6-gauge wire away from the panel, and I'm just going to focus on the ground wire. So the first thing I'm going to do is just tie in this ground wire, and I've got a ground bar bus and I've got a neutral bar bus over here that I can tie into. So, and also a neutral bar bus on this side as well. So both sides I've got a bus line I can tie into. But first I'm going to tie in the ground, and then what I'm going to do is I'm going to start removing breakers and work my way down with the breakers so I can bring in two 50 amp EATON breakers. And the idea is that the top breaker is going to be the one that's going to bring in the current for my generator, 220. This will be putting power on both legs. And then I'm going to do another 50 down below these two. I think it's like hot water heater and maybe the stove. But I'm going to bring this one down below those two. So I'll have 450 amps on this leg. And this one will be for my TIG machine that I want to tie in. Since I'm doing all this together, I want to just kind of add it. But I'm not going to focus on the wiring up for the weld machine. I'm just going to focus on the generator tie-in to power essentially my whole house. Already talked about the soft start and everything, so now I'm just going to focus on wiring this into the breaker box, which is the next step. So I've already got a 90 on my ground. I made sure that nothing is kinking here. The grommet, everything looks good. There'll be no rubbing. So what I'm going to do is I'm going to tie in this ground wire right into this ground bus bar. So I found an empty slot here, and I'm just going to tie that in. Let me tie that in just like that. Tighten that down, make it nice and snug, okay? And neaten it up just a bit. And I'll come back and neaten this stuff up later. They did a good job on this breaker box with how clean the layout of the wires, very neat. So one important thing that I've mentioned before, and I want to mention again, is making sure that you're being safe, that you have consulted with an electrician, or you have an electrician preferably do this work for you. I've done this many times, and I have a lot of working knowledge of at least how to do this particular type of job. So I'm comfortable with it. But number one is making sure that you are confident, you know what you're doing, and that you've got all the power turned off, and you've got a really good meter, and you're always watching the power coming in on this. So that's super important, and that's one of the things that I've been doing, is making sure that I'm being safe and I'm not going to have any mishaps here. So I have the main breaker off, we've got main power off on the back side. So we're doing good. And of course, periodically, you know, I'll just check and make sure that I don't have any power on each of these legs. So very, very important that you are playing something here that can take your life. So super, super important you know what you're doing. All right, so now that we've got the ground wire out of the way, let's go ahead and just start pulling these breakers out of here. So they snap off the ground side. There's a couple tabs here, and they snap onto this back side, which is a neutral. And I'm just going to bring them down. Now you notice that they are wired coming from the top. So fortunately, they gave me enough length that I can work with, so I can basically just bring each breaker down. So that's the idea, is I'm just going to come off, and I'm going to bring each breaker down. And again, I'll neaten all of this up once I get done. So my way of doing things here, probably everybody's got their own path, their own best practice. This is just how I prefer to do it. So I'm going to come down, pull all these off. All right. And then now I'm getting to my two 50 amp breakers here. So being safe, let's just double check to make sure we still have no current coming in here. We've got nothing on that leg, and we've got nothing on that leg. That's very, very important to make sure we don't have 240 running across those two. Nope, we're in good shape. All right, so let's get these 240 breakers off here. And a little bit more work there to get those off. And they come right off the back there. All right, so now that we got that off, let me grab a microfiber. So I'm gonna grab a microfiber towel here and just clean off the top section. Clean off these breakers while I have them out. It doesn't hurt. Just kind of wipe off the top section of these breakers. Get them clean. And again, I'll come back and neaten this stuff up. All right, so next what we want to do, we want to come in and we want to put our 50 amp breaker in. So before we do that, what we want to do is we want to take and we want to measure a length of how far up we want to go. And yes, I could go ahead and place these down, you know, go ahead and lock these in place and do these. And I may do that just to show the difference in a couple different ways to do it. But what I want to do is I want to come up, I want to show the length that I need. I'll probably measure just a little bit more than what I need, but let's come in here and let's base it off this top here, because this is where I'm going to be coming in. So let me grab my wire cutters, and I'm going to come in and I'll leave a little bit of slack, because what I can do is come down and pull a 90-degree bend on this red wire. So I'm going to leave a little bit of slack there, And I'm gonna cut that wire right there. So let me cut that wire. And this is 6 gauge. So it is not the easiest wire in the world to cut. And then let's go in here and let's cut this black leg. So these will be my 2 hot lines that are coming in. So what I'm gonna do, I'm gonna come in here and I'm gonna strip the insulation off. I just wanna cut around that insulation without taking any of the copper off, just like that. I want about that much off. So I have not about a fingernail. It's usually how I measure. And then I'm gonna come over here and I'm gonna do the same. Go around. All right. So now we've got our 2 pots. So this will be 110 and 110, or 120, 120, whichever you want to call it. But essentially these will be allow 240 volts to come into this breaker. So so what I'm going to do is, now that I've got those cut, I'm going to go ahead and get my breaker set up in the position where they need to be. And then I'll check the wiring again and we'll see where we're at. But first breaker I'm going to start with will be my generator breaker. So there's a little clip on the back here. And let me make sure that I got a good angle on that. So you can see that little clip. It's almost like a little hook. And that hook is going to clip in on the back. And then these 2 legs here will slip into each, they'll slip into each leg on the breaker box. So this will be 110 volts, which will provide, or 120, 120, which will provide 240. And they just snap in, just like that, onto that bus bar. So hook, pivot, snap. So just watch. We come in here, and again, I'm not trying to teach anybody how to do this. I would expect you already to have working knowledge of how to install breakers in your breaker box. So it just snaps in just like that, nice and easy. So what I've decided to do is just come in first with my generator. So you can see I've got, these are coming down from the bottom. So I'm gonna pull a little bit of slack down here from the bottom. And let me grab the black and pull a little bit. There we go. And again, I'll neaten all that up at the bottom later. So what I'm gonna do now is I'm gonna come in and I'm gonna continue with the household breakers next. So that's 50 amp. And then here we go. This will be another 50 amp, right? Which will continue right below that. So this will be my generator, house. And now what I'm gonna do is I'm gonna come down and I'm gonna, because I have enough slack here with the lines that they brought in from the house, thankfully, and everything is done really well, I'm gonna bring in my welding 50 amp breaker next. So this one I'll wire in later, but I just wanna get everything in place so that way I can be sure all the wires are tucked into the nice spot and everything looks good. So there you go. Everything looks good. Let's just make sure that's tucked in there right. There we go. All right, so generator, house, welding machine, or 240 outlet for whatever I prefer to do with that, whether it's plasma, welding, etc. So now what I can do is I can continue down with my existing 110 legs. So let's give me some slack there. And here's what I'm gonna do. I'm just gonna punch that in, just like that. And I'm gonna continue all the way down. Let's punch that in, just like that. Punch that in, just like that. And these are GFIs, so they're testable breakers. That's why they look longer and not these little short breakers. Have the GFI built in, so they're a little more involved. But again, no big deal. Just want to be careful and work each one of those in just as you have before. So there we go. So I tell you what, this one here, since that is the bottom breaker, that one belongs, actually, this one belongs down below. So I want to do it in this order. And this is just my preference for my home. So there we go. And now, since this one's coming up from the bottom, I have more control on how I neaten the wires and take care of everything down here. Because I am running out of room and I want these wires, I want them to follow the same pattern in the same order that I had pre-existing. So I'm not changing anything there. Let's get in this last one here. So just like that. So good. now we've got everything nice and tight. Everything looks good. Let's check the voltage one more time just to be safe. We've got nothing on that leg, nothing on that leg. Got nothing. All right, good deal. So yeah, now we're making some good progress here. So what we want to do now is we want to come up with each of these 6-gauge wires, which are intended for our 50 amp, and we're going to come in here, we're going to tie them in right in here to this top breaker. So what I can do is I can go ahead now that we have everything already routed successfully. Let's go ahead and open up. Now, if you can see in the breaker, we've got two little openings here. I don't know how well you can see those, but because I've killed the power to the garage. But right in here, you've got two openings where each one of those 6-gauge wires are going to run. So we're just going to open up. There's 2 screws in the bottom. We're going to open those up. Give us enough room to allow the 6-gauge wire to fit in there, just like that. And what I'm going to do is I will go ahead and run the first wire in, and you can see you want that wire to go in where there's no way for you to see exposing copper. You know, the idea is you want the insulation to end right where the end of that socket ends. So let's tighten this up. Let's tighten this bad boy up here, just like that. Okay, and now let's go in here with the other one. Let gravity pull that down, and let's tighten this leg here, this particular socket. So this will be the other 120 volt. Tighten that down. All right, there we go. And you just want it snug. You don't want to, obviously break it, or you don't need to tighten the hell out of it. So what I'm going to do is I'm going to come up here, and usually you could take your wire strippers, which have a special, little slot here on the end where you can take and twist the wire. In this particular case, I don't know if 6-gauge is going to be really easy to do, but we can give it a shot. And I want to make sure that I have the length right. So I want to go down, and I want to bend the little 90 right there. And then right here, I want to go a little bit down and bend a little 90 right there. So just like that, I've got a nice 90-degree bend coming off of that breaker, which will follow right down the side here, nice and clean. So let's take and hook that breaker nice on the back and snap it in. And now you can see that we've got a nice clean 90-degree bend there. And then what I'm going to do is I'm going to take it, I'm going to do the same. I'm just going to kind of take and do a nice little 90 right there, just being careful not to strip the insulation. I'm going to take a nice little 90 and bend it there. So that way I have 2 little nice bends coming up that will nicely match each wire there. Look at that. Looks great. And now that's going to follow the same pattern that was done previously for this breaker box. So all my wires are nice and tight down the back side. No wires are rubbing. Everything looks great. And again, I will neaten up all this down on the bottom where everything will be nice and carefully done, where there's no rubbing. Everything looks good and clean and safe. So no fires. We want to make sure everything is really nice, connected and in place, and just triple checked. All right, so now we got to tie in a neutral wire. So we've got 2 neutrals. We've got a neutral down this side, and we've got a neutral here, a neutral bus bar coming down this side. So doesn't really matter which one I join to. I'm just going to join on the neutral that's coming down that's closest. It doesn't really matter, but you can see that's where these neutral wires come in here. And on the back side of these GFI breakers, there's a neutral connector to that neutral bus bar. So that's a nice way to know that you have a neutral connection there. So what I'm going to do, again, is I'm going to make me a nice bend here. I want to follow the same pattern. I'm going to just bend me a 90. So let's take and that 90, so we follow the same pattern, and I'm going to come up just like that, and I'm going to come right into there. So let's take and do another 90 there. So 90 there, right, and that red one can come down just a bit more. Again, I'll neaten all this up later, but this is the idea, is just to keep everything nice and neat. So, all right, we're gonna come right into that line. So what I wanna do, so I'm gonna cut this wire right to length. So I wanna go through this bus bar, this neutral bar. I'm gonna give me enough length. So I'm gonna go right about there. And again, 6 gauge, gotta have a little power, a little bit of power for that. So let's go and let's strip off a little bit of wire here. Go around, and they have every kind of wire stripper in the books, right? Automatic kind, doesn't really matter which ones you prefer. And I always cut myself somehow, some way, every job. Just I guess it wouldn't be right whether I'm installing engines in my Corvette. I don't know. I guess it's just part of my pattern of work here. So let's see which one I want. Okay, I wanted to come into the one above it. It's like my initiation to all the jobs I start. I have to slice myself open. So thankfully I have a little plug here, but a little blood won't hurt. Just rub some dirt on it, you know? That's how I was taught as a kid, to rub a little dirt on it. All right, so we're gonna come right into that neutral and let's work that in there. Again, we're talking about 6 gauge here. So a little bit of a tight fit, but it's going in there. Just gotta get my fingers. Look at that. Look at that. There we go. Perfect. All right. So now we got our neutral wire on the neutral bus. And let's tighten that down. Yep. Nice and snug. Okay. Good deal. So now we got our ground wire. We got our neutral wire. We got our both hots. And we are looking good. So let's yeah, there we go. Just like that. Looks great. Yes, I am a little bit of a perfectionist, so excuse me for sitting here fooling with stuff that really doesn't matter. It's okay. All right, so there we go. So now we've got our box mounted, and in fact, when I turn on the power and I flip this breaker and I flip this on, I believe this little green light, this little lightning bolt will light up here on the front. So so we'll check and see if that works. But most importantly, let's see if we can, let's check that first. Let's flip on everything. And then what we'll do is we'll plug the generator up and we'll see if we can get power into the house. Why not? Now, one of the final parts that I'm going to do to this, obviously, is an interconnect kit. So I'm going to show you that in the next phase of the video. That'll be starting here in just a bit. But what I want to do is just show you kind of the different phases where, you know, first we want to get our Nema plug mounted and then wired into the breaker box effectively. Of course, I did a little extra 50 amp here, which will come out, not exactly sure where, but probably underneath, and I'll do a welding plug. But I just wanted to show how this isn't incredibly complicated, but it is super dangerous. And I just want to throw that out there again. This is just demonstration purposes. I don't expect people to just follow me and, and then expect to get the exact same result. So this is just demonstrational. Keep that in mind. But I am showing you how you can do this legally and how this would be wired in with an electrician. So they're going to come in, they're going to do it the same way. And this will now provide 240 into my 50 amp breaker, which will power both legs. So if I had power killed at the lines, no power coming in from the lines, okay? So what would happen is I would flip this breaker off. My main would be off like it is now. I would flip up my interconnect switch, which would allow me to flip on my 50 amp, bringing in 240, 13K watts into my home. So 13K will definitely power at least this house. Obviously the size of your house, how many appliances, how many things running matters. But with a soft start on my AC unit, it will power that. And of course, people do this many different ways. I don't particularly recommend having every breaker on when you flip on your 50 amp breaker for your generator. What I would recommend is you turn everything off, you flip on, you do your interconnect, That way you are positive you have no power that can be backfed and hurt anyone working downline. So number one, turn your main off, flip your 50 on, go turn your generator on, flip your breaker on your generator, which we'll show shortly, and then you can start turning on power to your house, whether it be your air conditioner first or whatever you want to do. I would suggest doing all this ahead of time, testing and ensuring that all this stuff works before a storm, which is just common sense, right? Now these generators, especially the DuraMax and others, they say they need 8 hours of runtime at 50% throttle. So no idle, just running 50%, no load to break in with no synthetic fluid. And then after the 6 to 8 hour break in, you flip to synthetic fluid, and then you can put a load on the generator, which will extend the life is what they're saying. It'll just allow the generator to run, have a longer lifetime. All right, so I think we're in good shape here. This looks really good. The wires look really neat. Everything turned out the way I expected. I do have my panel here, which is labeled. So, okay, I think I was pretty close. It's dryer and water heater. So I think I said range and water heater. But so all of these are going to move down to, well, actually 4, because I did 250 amps. So the dryer and the water heater will take up these next 4 slots, and then all of these will move down. So this is just a sticker. You can do this many ways, but I'll probably just buy some stickers and then relabel these. Not a big deal. And again, these panels have a little flange here, like where you can hang it on a bolt. So you just want to keep that top bolt in, and that will allow you to hang it. And of course, I'm going to have to, so one of the things you got to do, if you haven't done already, is you need to pop out the pins that are down here. So you can twist them and they'll pop out like this. Just twist these pins just like that, and they come right out. So we want to do 4, right? So let's just show this part, because this is part of the process. If no one's done this, they can see that there's really not much to it. Just be careful, these ends can be sharp. You don't want to slice yourself up like I'm doing. But again, right on the panel here, let me set it where you can see it. These little pieces here just bend. They're got 2 little tabs, and you just keep bending them like that, and you'll feel it getting looser, and you just work it loose. So that way, without me getting any blood all over this stuff, I've got 1 screw up there remaining, and yep, these breakers need to go up just a hair, but there you go. So now you can see that that's nice and flush. I measured and wanted to mount this where it comes exactly up to my panel. There's about a millimeter gap once I get it all plumbed. But yeah, there you go. So again, this will move down, and that looks really good. So now that's a very clean way for me to basically come out, stay out of the weather, take my generator out to the edge of the driveway, and run my 50 amp line and power the house while I'm in a storm or any type of emergency situation. So not bad, not bad, not bad. So let's pull that back, and what we'll do is we'll stop here, and then we'll move on to the next phase of the video, which is testing the generator, powering the house, and seeing what we get. Next phase. So what we're going to do is we're going to demonstrate bringing power into the main breaker box. We're going to try to power the whole house, and I'm going to walk you through the steps of what you would do in an emergency. Say a storm came, and now is the time for you to, plug up your generator and get your generator running and bring power into the whole house. What are those steps? Like, what would you do? Okay, so virtually speaking, we're going to have an interconnect kit on here, and I will show you that towards the end of the video, the full thing. So I want this to be super comprehensive. That's why I'm doing this sort of in these different phases. So obviously, this is not how you would be working with an open breaker box. So keep in mind, I'm doing this under my own accord. Do not follow these steps. But I just want to show you, that way you're seeing, sort of this process broken down into details. And of course, it's done many, many times. But I want to show you that, hey, this is my way of doing it. This is my breaker box. You guys may have a very similar breaker box, and it may be very similar to this. And I want to show you that it can be done. And this generator, the DuraMax 13K, can power this house, especially on propane. So I'm going to be demonstrating that on propane. Okay, so one of the first things I'm going to do I'm going to turn off the 50 amp breaker, which is going to be coming in from the generator. I'm just going to do that first. Now, what I am going to do is I'm going to leave all the room breakers on just for this demonstration. I've got some lights on. I've got ceiling fans on. I'm going to go through and turn on some things in the house and show you that, hey, it is powering the house. So now the air conditioner, it is Wi-Fi. It's using the Bluetooth units, which do take some while to spool up. They have to connect to Wi-Fi. They have to do all this sort of synchronization before they'll kick the air conditioner on. But I will show you that just to show that, hey, it does work with the air conditioner. May have to be in the latter part of the video. I have to stop that. But I'll walk you through and show you that it at least is starting up and everything is on. So next steps. As you can see here, we've got heat, range, AC. So we're going to skip the range because most people typically won't need a range. I've got a gas grill, but I have no doubt it would probably power all of this. But in this case, I don't really care. I'm not going to power the range in a hurricane. If I do, I might turn off the hot water heater while I do the range and just be smart about it. No reason for me to stress the generator any more than it need be. But I'm going to power on all the rooms. And over here on this side, you can see dryer, hot water heater. So I'm going to turn off the dryer, turn on the hot water heater. I'm going to turn on heat and AC. I'm going to have those both on. So heat, skip the range. Here's my AC. Here's my generator. We're going to turn off the dryer. We're going to turn on the hot water heater. And this will be my welding machine outlet, plasma, TIG, etc. MIG. That is not even hooked up yet. We'll do that in a later video. But then the rest of these are my GFI, and they all go to my rooms. So as you can see, we've got inrush current. We technically have no inrush current. It's 0.05, so we have no power coming into that. You can see that our main is off, which is super, super important. And again, we won't be able to flip on this generator breaker with the interconnect kit in position. So in this case, main off, generator off. Let's start with the first step. That will be this Nema 50 amp plug. And they only fit the 50 amp. So you have to buy either a 30 or 50 amp, depending on what type of generator and what you're trying to do. But you want to plug that in. It only goes in one way. It's got these little notches, and then you turn it to the right, and that will lock it in place. So then you just take and turn this little black collar, and I'm doing this just with one hand here. So if I can do this with one hand, I'm sure anybody could do this. All right, there you go. All right, coming in. There you go. No problem. All right, let's follow that bad boy. So you're going to go back here. You're going to see we got propane. And yes, propane tank actually is a little bit low. So I will have a 120-gallon propane tank ready to power this, maybe a little bigger. But for now, I'm stuck with that. And I'm going to show you that I am on propane. So that will be running, I want to say, another 1,500 less watts. I'm not sure, but it's definitely not 13 Mac. It's probably around 11 on LPG. So all right, so let's see here. We've got our circuit breaker is off. That would be on. Here's our meter, voltage, hertz, and hours run. Here's our LP50. This will be what we're plugging into. So let's grab that plug. See, it's got this nice little handle here, and you'll see that it's 4 prongs. We're just gonna plug that right in there. Super easy. So in a storm, that's really it. I mean, you're just gonna flip the breaker. You're gonna plug in your extension cord from your Nema on your wall, going into your breaker box and your main breaker. And you're gonna plug in your generator, and then you're gonna just basically turn on whatever specific settings you need for your generator to run. So in my case, I'm gonna have idle control off because I have 0 hours on this generator. They say that you need 8 hours of break-in, so I'm just note that I'm stressing the generator a little bit just to show this video. But let's go ahead and flip the battery switch to on. Idle control off, breaker off, and let's start the engine. Let's see if we get a good start here. All right, okay, so everything's running. We got 240 volts, 62 hertz, and 0 hours, 0 hours. So let's go back. We're at 243 volts here. Breaker's off. So what I like to do, we still have no inrush current. Breaker's off, so we don't have the green light here. But what I'm gonna do is I'm gonna go ahead and flip the breaker on. Okay, this is coming from our generator. I'm gonna put that on, and I like to use the circuit breaker on the generator as the last switch to provide current into my main house. You can do it either way, but I would prefer to use the circuit breaker myself. This is my opinion. So now, when we flip this on, we should see the generator go down just a bit. Oh wow. So it's charging, 242 volts, 61 hertz. There we go. So now we have full watts of current coming into the home. Now we've got the green light. So we are hot. You can see my meter's now picking up power. So we're right at 8 amps on this leg. We've got 8 amps being pulled on that leg. Okay, right? So again, I've already told you what I've got on, which is practically the whole house. So let's go in and let's see. I mean, obviously my garage lights are on now. And just so you know, we're not pulling any tomfoolery here. Circuit breaker off. The main line off. Okay? Off. Now we'll be walking you through my house. Ignore any bit of mess, but again, this is just demonstration. So we've got light on in here. Alexa's not going to work because I don't have Wi-Fi, but you can see I have power. We've got power there. Here is my AC. So you can see it is waiting for equipment. So as I said, that'll take a little bit to come on, but I've got power to my lights, but these are Wi-Fi. So that's why you'll see a red there, right? But look, I've got light coming in and I've got Alexa booting up here. Straight into the outlet. Sensitive electronics are working pretty well. Okay, so now let's do this. Let's start up my laser projector and 3,000 watt Nakamitsu, however you pronounce it, Naka something stereo, which is pulls quite a bit of power. I mean, it's probably one of the highest consumption power things in the house, especially the laser projector. So you can see that's just on a surge protector. That's it. I will be buying a power conditioner, especially for my laser projector and sound system, just because I want that to be really protected. It's expensive units. But you can see that right now we're on generator power and boom, there we go, coming up. And of course, internet is booting up. Takes a while, but there we go. So let me see. Let's go and let's see if we can turn a fan on. There we go. So we've got our fan. There's our fan, right? Fan, laser projector. All right, bonus room is on. Now let's go into my office. Actually, let's just turn on. Wow. Fan is on in the bathroom. Fan is on. So, and here's my office. So quite a bit of electronics in here, and this pulls a lot of power. So let me show you. We're running my custom built water cooled PCs, dual monitor. This is an M3 Max Pro laptop, 16 inch powered. Again, this is booting up, so the LEDs look like complete crap right now, but when that boots up, they'll turn into a nice sort of purple and light blue. But you can see right there, I'm pulling 202 watts, just booting up. That is a custom water cooled 4090 right there on that system. So, and this system over here, let's go ahead and turn this one on. So starting up, we'll get some watts over there in a minute. But again, this is a Threadripper, 32 core Threadripper computer. Pulls a ton of power. And again, this needs clean power. So keep that in mind. So these are two water cooled rigs that just pulled 250 watts right there, just idling. Okay. So again, like this is a lot of power coming up. And here's my, let's go ahead, show you that it can run a computer, no problem. So let's go ahead and just load my profile for my computer. Look, there you go, two 34-inch widescreens, LG, hub, like look at all the stuff we're running now. Now you can see my color scheme is coming back, right? That's actually my real color scheme for my PC, but that's water cooled 4090, and that is a 14700K Intel chip. Top of the line, overclocked. Can't get any more power than that other than running like some dual Xeon or some high-end Threadripper, right? 128 core Threadripper. But again, both computers, monitors, all of it running. I have a couple Bamboo Labs. I'm not going to turn those on because I think you get the point. Probably won't be doing stuff like that in emergencies, but I can work. I can continue to do my job. I can develop code, build mobile apps, work in cloud architecture. I work in Azure and AWS most of the time. But this allows me to power everything I need. And I'm just demonstrating that, yeah, even the stuff you don't really need, even though LEDs don't pull a lot of power, no big deal. Look at there. And I feel the air's on. The air is on. Yep. I feel the air blowing. Look at that. On. Boom. It's cooling to 70. Check that out. Look at that. And there's the weather showing me that I have Wi-Fi So I have full Wi-Fi, full air conditioning running. I'll walk outside just to show you that. Kitchen lights are on. Essentially entire house powered, stereo, air, everything you need. And the generator doesn't even seem like it's like running hard. I haven't heard it surge one time. Right there, look at that. So let's go over here just to show you real quick that the AC unit. Let's see if it's on. Yes, it is. So there you go, right there. Soft start, I mounted right in behind there, the micro air. So it works beautifully. And again, even when that AC kicks on, it doesn't, you don't even hear the generator, like at all. It's just unbelievable. So minimum circuit amp ampacity, that's 25 amps minimum. So there you go. Train XR, powering it like nobody's business. So hope this helps, showing you that, you know, you can do this stuff. If you don't, hire an electrician. It's not that complicated. And you can be prepared and power this stuff yourself. So now I'm gonna do the reverse. I'm gonna turn the circuit breaker. I'm going to kill the power. I was at 60 hertz, right at 60 hertz. So I'm gonna stop. There we go. Turn the battery switch off. I'm gonna pull the power. And then I'm gonna come over here and see that I have no power coming in. Now what I would do, one of the things I recommend, since you're dealing with propane, you don't wanna mess around with leaks. So go ahead and turn your propane off. Something I would highly recommend. So that way you don't have to worry about any fumes or any kind of, you know, anybody getting hurt or dying from fumes or stuff like that. Always adequate ventilation. Carbon monoxide, these generators put out a ton of exhaust and carbon monoxide. So keep that in mind. And to remove, you just do the reverse. Boom, just like that. Flip it to the left, pull it out. And because we don't have a little electrical guy there, it's not hot. So let's close that. This time around, we're gonna do the reverse of what an interconnect kit does. So let's flip off the generator, right? Now we have no power coming into the breaker, no way to backfeed into the lines. And I'll show the interconnect kit in the last part of the video, which will make this completely safe and legal. And then now I can go ahead and I can flip the main power on, boom, just like that. So now we got the main off and I can now put on, well, I'm gonna leave the welding one off, but now I've got all the power coming into the breaker box. Obviously I'm gonna turn that back off and I'm gonna neaten up the wires, finish up everything. But hopefully this helps, guys. I just wanted to show you that you can power a whole house right there, no problem. Not even skipping a beat off of a 13K. In fact, you probably can get away with a 10K. I mean, honestly, if with a soft start, I don't even see the house even straining this thing. But again, just my thoughts. I like to be a little bit more prepared, and I'm gonna use the generator for other stuff, possibly welding, etc. So got a good deal on it, can't beat it. I think I paid $1,800 or something with tax. That is a killer deal for what you're able to do, especially in case of emergency. So now, a few simple steps, guys, and I have a whole house powered up. Thanks for watching this video. I'm gonna show you the one last part, which is the installation of the interconnect kit. I hope that you like these videos. I don't do a lot of them. Most of the videos I do are kind of long-winded because my particular needs are just really helping people. I am not out there trying to clickbait and get tons of views. Could give a crap about that, honestly, which is why you don't see me posting a lot of like clickbait car racing videos, which I have a ton of with my Corvette. You know, I'll do some more stuff, but really I enjoy the videos, the niche videos, the things that truly can help people at the end of the day. So I know that people have had a lot of terrible things happen to them with these storms, Helene and Milton, and this is just a good time to show that you can be more prepared. So I thought I would throw my 2 cents in, maybe help a little bit in my way. This is kind of my way of helping. So hopefully you guys get something out of this. And if you have any questions, you know, feel free to ask, shoot in the comments. Yeah, thank you. And we'll move on to the last part, which is the interconnect kit. And we'll see you later. Okay, here's our last part. If you have watched this entire crazy long-winded video this far, then congratulations, because this is a very long-winded video. I know it's gotten very detailed, and I probably repeated myself probably 50 times now. That's just who I am. So again, I'm not some YouTube star here. I just want to make videos that help people. So, all right, last part, promise I'll try to make this short and sweet. So what we're going to do is we're going to wire up this interconnect kit. I got this off Amazon. I think it might have been $15, $20. This is a model GK PN200 for 200 amp breaker box kit. It is called XLFU. I'm sure I'm saying that wrong, but that's the way I read it. Excuse me. All right, so per the instructions, we are going to put this little template piece here, and what I'm going to do is probably just knock it with a punch, but let me place a couple little marks here. Place a couple little marks, that way I know that I have this in the right spot. So let's line that up nice and sweet. Let's put a mark there, mark there, mark there. So what that's going to allow us to do, if we look at this thing, and of course you can put this panel back up on your box and, you know, line it up and make sure that everything is right. But essentially what's going to happen is this piece is, there's going to be some screws that come through from the back, and this piece is going to slide up and down. So when it's down, that means your main breaker, which will be on right here, your main breaker is on, and this little tab here is going to prevent your 50 amp generator breaker from going over, as you can see in this particular picture. So when you want to power your generator, you're going to flip the main power over, and then this bad boy will slide up, as in this diagram, and then you'll be able to flip your generator breaker over. So it's not very complicated, but I like that. I like the keep it simple method, and really it's just, you can't screw it up. And when you're talking about killing yourself with 240 volts, yeah, let's keep it simple. All right, so they give you a bit. Bit is with the kit. So I made a couple marks there. What I'm going to do is I'm going to punch a couple holes. It's probably going to make a bunch of noise here, but let's just punch. And let's just punch. And let's just punch. Let me get that in the middle there. And I think I got it. There we go. All right, that will allow me to get a nice clean starting hole without using a tiny bit. So I have some plywood. I don't want to drill into my butcher block worktop here, so I'm just going to go right through that. Super simple. There we go. Keep our safety glasses on while we're doing this stuff. I've had metal in my eyes. My dad actually passed away, died on the job, in fact. Pipe fitter welder. He died when I was 16, but taught me everything I know when it comes to welding and fabricating and pipe fitting and electricity and all of this stuff. And I've just always been fascinated with it from the time I was little. I took everything apart. But he was grinding and had a piece of metal go way into his eye and had to go to the hospital and have it surgically removed. So I cannot stress enough how important eye protection is. Super, super important. I feel like I'm like Yoga Bear over here, being everybody's big brother. All right, we got our 3 holes. So usually you want to measure 3 times and cut once, but in this case, I just measured once, cut once. So let's hope that that's right, because I just drilled 3 holes into my breaker panel. All right, love my Bluetooth shop vac. Killer, so worth the money. Yes, sir. Love it, love it, love it. Yes, sir. All right. Then I got my nice Freaky Fit workbench. Freaky Fit. See if you can see that. They're lightweight, man. They're killer workbenches. Love them. And comes with a cup holder. All right. So in this case, next steps, I believe we're going to flip this thing over. So we've drilled the holes marked on the panel cover with a 4.8 millimeter drill bit. We're going to insert screws from the rear of the cover, install the bottom plate, and install the slotted plate on top. It says install thread lock to screws and retaining nuts, so they didn't provide any thread lock, so let me go grab some. I got plenty of thread locker. That's something that, especially working on cars, building engines, etc., you want to have a lot of. All right, so what we're going to do, let's look at the instructions. We're going to come through the back, and we're going to come in through the slots on the front there. So let's get our screws out. I am literally reading these instructions and doing it for the first time. How about that? That way you guys can see that I'm not, pre-planning this stuff. This is exactly how you should do it in videos, Let's show the real world stuff, right? So if I screw up, you're going to see how most people would probably screw up and learn from it. So that's the idea, right? So let's grab those, put a little tension, and there. So now that we got our screws through there, let's go ahead and put a little blue Loctite. You know what? Let's see what kind of nuts we're working with there. Just do a little bit in there. There we go. There we go. I don't think I would suggest red Loctite on this, even though you probably won't remove it, but red Loctite comes off. Just got to put a little oof behind it. Okay. All right. So now, geez, right when I took my glasses off, I probably should have put my glasses back on. So if I'm reading that correctly, I think this stays on. Let me put my glasses back on. Okay. So as shown in picture 2, install the generator interlock kit on the top right side and place the generator warning sticker on the generator breaker. All right, so it goes like that, just like that, and it slides just like that. So main power is on, and you will not be able to flip the generator power. That's the idea. So let's start these. So it's saying to use the zip ties. I was wondering what the zip ties were for. Combine the zip ties and make a loop around the top set of breakers in the panel. Pull the ends tight around the breakers. Trim up the ties as needed and install the warning label to release the tab on the zip tie at the generator breaker. So what they're saying is put these end to end, and you can wrap them around the breakers, and it just kind of helps hold everything. I don't need that. You know, again, this is probably if you're trying to do it up on the wall. I don't know. All I know is sometimes, you know, being a man, you don't need all these instructions. What do you need these instructions for? You know, what do you need these for? We're gonna man it this time. And if I can man it without even reading all these instructions, just by going by the pictures, then I think anybody can do it, right? So here's our warning label going that way. I mean, come on, it doesn't take a rocket science to figure that out, right? Okay, so let me grab flathead. Grab a flathead screwdriver. Okay. And let's see. I can tighten that down a little bit. And I'm gonna see if I can make these nice and pretty and line up equally. If I can do that, oh, that would be, I'd be smoking. What? I would be smoking. All right, here we go. I mean, come on. I built 1,000 horsepower actually 1,200 wheel horsepower engines. I can put an interlock kit. Come on. There we go. Boom. And because I'm pushing down, it's creating a little tension on the back of those Phillips head screws on the back, and holding it enough to where I'm able to tighten down these top bolts. So we are done. It says install warning label next to the release tab on the generator breaker. So we've got all these warning labels. So we'll put these in the right place. We can do these later, but essentially it's saying attention or caution, portable generator on site, generator inlet located at blank of building. So it's really, I could just put an arrow to just point like right there, because that's where it's at. Yeah, giving you a couple labels in case you mess up, and you can put them wherever you want. So yeah. And then this one, oh, Lord have mercy, my glasses back on because of my old eyes. Okay, do not remove generator breaker retaining strap. If breaker needs to be removed after installation, press release tab on strap and reinstall when complete. Okay, so that's what these are for. So we can wire these up into the breaker box. I'll just do another video. I'll move over there. Not 100% sure, like, if these are required. I mean, honestly, like, if legality depends on zip ties, I mean, I'm a little bit taken aback on that. I don't know if I want plastic zip ties inside my breaker box. So again, I need to rethink that and do a little bit of research, but we'll see here shortly. I just want to read this. If breaker needs to be removed after installation, press release tab on strap and reinstall when complete. So really what this seems to be doing is just holding the generator breaker down in place. Combine the zip ties to make a loop and install zip ties around the top set of breakers in the panel. Pull the ends to make tight around the breakers. Trim zip ties as needed and install warning label to release tab on zip tie at generator breaker. So they're talking about looping around the top 50 amp breakers and holding them together. I don't necessarily understand that. I don't really know if, I don't know if that is required or not. So why don't I do a little bit of research on that, and then if it is required and if it is necessary, I will continue with that in the next part of the video. But in this particular part of the video, we're done. That's it. That's our interlock kit. Boom, boom, boom. Right? Simple. Love it. Blue Loctite. Remember, you don't want this really wiggling loose. Not that this vibrates or anything. Just calls for it. Can't hurt. But I don't think you need blue Loctite, just truthfully, just based on my experience. But all right. So let me dig into the whole zip tie thing. Honestly, I've never heard of the zip tie stuff. Haven't done tons of interlock kits. So again, let me research that, make sure that's okay. And if we need to install it, I'll do that part in the next part of the video. If we don't, then I won't. So next phase of the video, I'm going to hang the panel and I'm going to demonstrate the interlock kit. Finally, we are at the last part of the video. So let's wire up this interlock kit and answer one of the last questions that we were talking about, which was, what the heck were these two zip ties for? So apparently there's a code 40836D, which says backfed devices shall be secured in place by an additional fastener, which is other than a pull to release, which is just like a standard breaker pull to release. So what they're saying is this meets, and I'm sure that this is the minimum requirements. There's probably much more secure ways to do this, but this meets the minimum legal requirements of holding down this backfed breaker, which is other than a pull to release breaker. So this fastener will slip up under here. And again, I'm doing this for the first time, so we're learning as we go here. So what I'm going to do is wrap that around like that, and I've got that in there like that, got that in like that. Tell you what, I've already checked once, but just so I'm showing you guys good habits, good practice, let's check and make sure that we've got no AC voltage on these legs here. So we have nothing from ground to ground. All right, so we've got main breaker off, we've got no power coming in. All right, so let's secure this zip tie per directions around both of these top main breakers, right? So let's get that right in there, and let's wrap that right around there, and let's tighten that down. So what we want to do is we want to get that where it comes right around number 2 and 4, and we're going to tighten that down just like that, where we get a nice, secure, even connection there. Right, so let's pull that. Let me grab my cutters here, and let's pull. All right, pull. There we go. All right, so now what we did is we've got these fastened, okay? We've got these two fastened. Let me make sure that we've got the right camera angle there. So if you see right at the top, let's see if we can get a good shot. Let's bring the camera around. So you can see we went right around these two top breakers with the zip tie. We doubled it up. Now I have longer zip ties. I may come back and redo this with a heftier, long. I've got a single black, thicker, more professional zip tie, but this fits the bill. I mean, this is the idea. So you want to go around both of these top main breakers. You want to pull that tight where it pulls them together. And then what we're going to do is we've got a sticker that we're going to attach right around that zip tie. So here's that do not remove. So generator breaker retaining strap. If breaker needs to be removed after installation, please release tab on strap and reinstall when complete. So you just pull the sticker off, you wrap it right around that zip tie right there. So let's do that. Let's set everything back up. Let's zoom out. So what we're going to do, we're going to grab the sticker here, and we're going to go right around that zip tie like that. Okay. Boom. just like that. And now we've got a do not remove. So let's come up and show you what we're working with. So now you're familiar with doing this whole shebang. So we've got the do not remove right on the zip tie, giving the warning, showing you exactly what it's for, so that we're following spec. And that's if, you know, an electrician comes in here, doesn't know who the heck did this. They have at least the legal requirements of what's been done, so that they know that, hey, that breaker is designed to be backfed. And that's what all this is intended for, right? Is to just follow requirements, keeping everyone safe. So let me set that back up. So now that we've got everything done within our breaker box, again, I may come back and probably will, and I'll neaten up the wires to absolute perfection, which nobody ever sees, but that's just the way, it's the way I work, it's the way I code, etc. But it looks great. Everything looks really good. Tested, nothing's rubbing, all the breakers look great, everything's in good shape. All right, so now let's hang the breaker panel. I left one screw at the top, so I'm just gonna hang it right in there. Left that one screw, okay? So right in there like that. And now we can see our interconnect kit, right? So our interconnect kit, now that our power is off, all the way off, we can flip that 50 amp breaker on. See that? That's exactly what that is designed to do. So with that on, we can't flip this all the way to full power. It won't go. See, it just will not, it can't go, it's impossible. And that is exactly what this interconnect say that 50 times fast, interconnect kit is designed for. Keep you safe. Cannot backfeed, no way, no how is that 200 amp breaker being flipped if you have power, or at the very least, if you just have this breaker flipped to on, won't happen. So when you flip it off, that can come down, now we can flip main power on. So very good. So before we wrap up the video, let me put in the last screws here. Let me do that, and we'll just do the interconnect one more time after we've got everything in there. So let's get that. Let's make sure we got all of our panel in there right. So in fact, let me loosen this up just a tad. Okay, and let me grab my Phillips head. So let's do this. So what we want to do is make sure our breakers are lined up, make sure our panel's lined up, and I'm going to put this top screw in, which will help hold the load, keep this panel from going a little bit to the left there. And in fact, that is a flathead, it's not a Phillips. So I grabbed the wrong screwdriver. So let's just see if I can get it with my drill here, or my impact. Okay. And let's grab the last screw, come in over here, like that, come in over here, okay. Boom. Okay, good deal. Got a little blood on there, you know, hey, it happens. So there's our panel, there's our interconnect kit, here's our Nema generator. I mean, total time spent, probably a couple hours. I could have absolutely done this in half that time, no problem, but trying to video and get everything kind of set up and narrate takes a little time. But, so now, what I'll do, just show you the interconnect kit one more time. Our main power is off, so interconnect kit can now go up. We'll flip the generator power, which would come in through here, right in through there. Generator power now is on, so this interconnect kit will not go down. No way, no how, cannot flip that. So let me bring this over a little bit closer, because I feel like this is one of the most important parts. So interconnect kit, when it's off, when the generator power is, breaker is off, it allows this interconnect to slide down. You can flip main power on. So with the main power off, so here's the deal. We lost power to the house, lines are down, we're in a bad storm. We're gonna flip the main power off. We're gonna slide up the interconnect kit. We're gonna flip the generator power on. And then we're gonna go over to our generator, which is probably and hopefully warmed up. You don't want a cold generator immediately powering the house. Make sure you warm that up. Have this on, and then go over and flip the circuit breaker after generator. That's the steps that I would recommend. And now that you have seen all of the steps here in thorough detail by someone who has really rambled on in every which way, hopefully you've understood that this is really nothing to it. Any of you guys could do this, but just be careful. Just number one, make sure there's no power, which is just common sense, right? But you'd be surprised how many people stick the fingers in there and just don't realize it. So, but yeah, so I'm gonna demonstrate real quick. So with that breaker on, I can't turn my main power on. So now what I'm gonna do, I'll flip this off and I'm gonna turn my main power on. There you go. And as you saw, we have light. It got white. So our garage light's turned on, and there we go. So now all I need to do is pull this off, relabel, and I'm in good shape. So hope you guys enjoyed the video. Sorry for it being a little long-winded, but I just wanted to make sure that I covered everything, and I could cut this down and narrate it, but I like it. I like being myself. You know, you can fast forward and all that good stuff. You don't have to listen to me ramble, but if you have any questions, just shoot to me. If you have any questions about the generator, the DuraMax 13K, or even the Champion, the smaller stuff, any questions about wiring this up, any questions about the AIRGO Soft Start kit, just fire them to me. Happy to help. That's what I love doing, and that's why I do these videos, just to help people out there. So, all right, guys, take care and be safe.